Good day everyone, and welcome to where we are putting together solutions in those math and science areas that students are getting problems with. This video will be dealing with CSEC Mathematics and in particular the topic of vectors. And this is our third video in this series, doing past paper questions from May 28, 2019 until the present. Feel free to like the video and add any comments down below so we can make other videos to help you in any particular areas that you are struggling with. Don't forget to look at the description down below where we have highlighted the order that we suggest you follow the videos in order to complete the entire CSEC syllabus. That math syllabus will have the past paper solutions from May 2009, 2010 straight up to the present year. So you can follow it and get a better grade in your CSEC math results. Let's take a look at the list of topics for CSEC Mathematics, and we can see there are 10 of them. This video deals with the 9th one, vectors and matrices. Those two topics combine for 4 past paper questions in the multiple choice, so 4 marks in paper 1 out of 60. And the last question that appears in paper 2, which is worth 12 marks out of the 100. And this topic of vectors and matrices is compulsory, so that means it's worth at least 16 marks for us. This video deals specifically with vectors from 2019 onwards, and let's remember that 2020 there was no paper 2 as due to the pandemic. May 2019, number 10b, relative to the origin O, 0, 0, you can see that on the diagram, the position vectors of the points A and B are OA is equal to 9, 0 and OB is equal to 3, 6 respectively. What does that mean? It means that if we start at O and we move 9 units to the right, then that will give us A. And we can see that from our diagram. And if we start at O and we move 3 units to the right and 6 units up, that will give us B. Now let's continue. The points D and E are on AB and OA respectively. And that's such that AD is equal to 1/3 AB. So if we look on the line AB, we will see D is represented there. And since it's 1/3 of the way, the entire way, let's break it up into 3 parts. So the first part from A to D is 1, and the other would be 2 parts. So 1 and 2 is 3 parts out of the whole 3. And OE, similarly, we'll put in the 1 and 2 out of the total of 3 parts. So the following diagram illustrates this information, just as we read. Express the following vectors in the form AB as a column vector. So part 1, we're looking at AB. AB is already given on the line. So how do we move from A to B? Let's take a look. To move from A to B, we start at A and we head to O. And then from O, we continue into the direction of B. So let's write that down. AB is equal to AO plus OB. And what are we given? We are given OA. What's the difference between OA and AO? It's the same values except in the opposite direction. And how do we represent that? By putting a negative sign. So we can replace AO by stating in the second line of our working AB is equal to minus OA plus OB. And if we substitute our values that were given from above, then AB is equal to minus 9, 0 plus 3, 6. And we can solve. Minus 9 plus 3 is equal to minus 6. And 0 plus 6 is equal to 6. So AB is minus 6, 6. And if we look at our sketch, to start at A and head to B, it means we're moving 6 units to the left. And then plus 6, which means 6 units up to get from A to B. Now, the second part, do the same thing for OD. Now, how do we go from O to D? Let's take a look. We start at O and we head to A. That's one path. And then from A, we can go to D. So that will give us OD is equal to OA plus AD. Now, just before we continue and we'll solve it, Is there any other route we could have used and still gotten the same answer? Yes, we could have gone from O to B and then from B to D. As in many questions in mathematics, there are multiple ways of solving it. There is no fixed way to say that this is the only way it works. So let's continue. OD is equal to OA plus, what is AD? It's given in the question above. AD is equal to 1/3 of AB. And we have the 1 there to indicate that fraction. So let's substitute. OD is equal to 90 plus 1/3 of minus 66. And we could work out 1/3 of minus 66. 1/3 of minus 6 is minus 2. And 1/3 of 6, 3 into 6 is 2. So now we solve 9 plus minus 2. And that will give us 7. And 0 plus 2 is 2. So we have OD is equal to 7, 2. Which means if we start at O and we want to end up at D, we can move 7 units to the right and then 2 units up. And finally, for part 3, we want to find BE. So let's take a look. How do we go from B to E? It kind of looks like it's going straight down from the sketch, but the sketch is not exact. It's not drawn to scale. So let's find a path. To go from B to E, we can start from B and head to O. And then from O, we can head to E. So let's write that. BE is equal to BO plus OE. And of course, there are other routes. We could have started at B and head to A, and then A to E, and you would still get the same answer. So let's substitute. BO is really minus OB, same length but opposite direction, plus what is OE? And that's given up above as well. OE is equal to 1/3 OE. And if we substitute, we will get minus 36 plus 1/3 of 90. And 3 into 9 is 3. So we could solve the top. Minus 3 plus 3 is 0. And minus 6 plus 0 is minus 6. So BE is telling us that there are 0 units to the right or left, which means we're only moving vertically. And how much are we moving? We're moving 6 units down. So this sketch makes sense. May 2021, number 10. In part C, the diagram below shows triangle OAB in which the vector OA is represented by R, as you can see on the diagram, and OB, that vector is represented by S, that's the base. You see that on the diagram as well. In addition, E is the midpoint of CD, and OC is equal to 3/4 OA, which means for the entire length of OA, 3/4 of it will be from O to C, 3 parts out of 4, which means 1 part will be from C to A, or 1/4 of the entire length is CA. And 2/3 of AB, 2/3 of the entire length is AD. So we can show that as well, that there are 2 parts from A to D, and the remainder is 1 part from D to B. Write in terms of R and S in the simplest form an expression for part 1, CD. So how do we go from C to D? We can go up from C to A, and then we go bottom right from A to D. We can also pass the other route from C to O, O to B, and B to D. And both of them will give us the same answer. Just as in many, many maths questions, there are many ways to solve each question. There's no fixed method. So let's go from C to A. What is that? That is a fraction, 1/4 of OA. And what is AD? It is given above as 2/3 AB. We know OA already, that's R, but do we know AB? That is not given, so let's go solve for that one side. How do we go from A to B? We go from A to O, and then from O to B. So let's write that down. AB is equal to AO plus OB. And if we substitute in, AO is minus OA, and OB remains. And if we substitute for R and S, we'll get minus R plus S. So that's the AB. We're now going to substitute into there to look at our third line of working. It's going to give us 1/4 R plus 2/3 of what we just solved for AB, minus R plus S. And if we expand the brackets, we're going to get 1/4 R 2/3 times minus r is minus 2/3 r. 2/3 times s is 2/3 s. So we're going to get a 1/4 r minus 2/3 r. Remember, you have a calculator. You can put it in fraction mode and solve, and that will give us minus 5/12 r plus 2/3 s. And that is CD. Now, in part 2, what is OE? So how do you go from O to E? We can go from O up to C, and then from C to E. So let's write that down. OE is equal to OC plus CE. And what is OC? OC is a fraction of the entire length of OA. OC is 3/4 OC. 3/4 of OA. And what is CE? Remember, E is the midpoint of that line. So CE is a half of CD. And we just solved CD in part 1. So let's substitute. 3/4 of OC, 3/4 R, plus a half of minus 5/12 R plus 2/3 S. And all we're doing is we're multiplying by the half in the brackets. So we're going to get 3/4 R. And if we multiply half times 5/12, 1 5 is 5, 2 12s are 24. So minus 5 over 24R. And multiply a half by 2/3 as well. Remember, we're multiplying each term by a half. So as we expand the brackets, the 2's can cancel. 2 into 2, 1, 2 into 2, 1. So we're left with 1/3 S. And we can use our fraction calculator mode again and solve 3/4 R minus 5/24 R. So that will give us 13 over 24 R plus 1/3 S. And we now go on to part D. The points O, Q, and R given on that graph have coordinates 0, 0, because that's the origin. 5, 2, 5 units to the right, 2 units up, that's Q. Take a look at, you'll see every other line is a whole unit. So the middle points will be 0.5. 0, 0.51, 1.52. They didn't indicate the middle ones, they just indicated the whole numbers. And minus 1, 4 respectively, which means from O we go 1 to the left and 4 up to get R. Write OR as a column vector. So OR is minus 1, 4 is given. So we just write it, instead of moving it from a row vector, and write it as a column vector. Good. Last part of the question, determine modulus QR. So if we're looking at from Q to R, we can make that, how do we get the length of it? We can make it into a right angle triangle. And if we have a right angle triangle and we want to find the length of QR, that's really finding the hypotenuse. So if we want to find that, we can use the rule Pythagoras theorem. So if we apply that, O squared plus A squared is equal to H squared. H being the longest side, which is what we want to find, QR. So if we substitute for there, we can see for the other two sides, we went from 5 to minus 1, so that base is 6. And then we went up from 2 to 4, so that height is 2. So if we substitute, we get in 6 squared plus 2 squared. 6 squared is 6 6s are 36, 2 squared is 2 2s are 4. So that will give us 40 is equal to H squared or QR squared. So QR will be the square root of 40. And that here, as you work it out, those units will be the actual magnitude or length of the vector QR. May 2022, number 10C. In the diagram below, O is the origin, OX is equal to U, and OY is equal to V. OX and OY are extended so that X and Y are midpoints of OA and OB respectively. So if we look at our diagram, we can spot that OX is U, and since X is the midpoint or halfway between O and A, then we can say the length from O to X is the same as the length from X to A. So it's like a ratio 1 to 1. And similarly, OY is V, and Y is the midpoint of OA, so therefore the length from O to Y is the same as the length from Y to B. So 1 to 1. Part 1. Express bx in terms of u and v. So let's bring up a purple line showing us the vector from b to x. And how do we go from b to x? How else can we pass? We can start from b and head to o. That's bo. And then from o we can go to x. So bx is equal to bo plus ox. And what is bo? Bo is really minus ob, meaning ob in the opposite direction, plus ox. And we can substitute there. What is ob? Ob is 2v. So we'll have minus 2v plus u. Part 2. Given that ya and bx intersect at m, so let's bring that up. We already have the line which is purple, the bx line, and let's draw a line in green from y to a, and we show the point of intersection there as m, and the bm is equal to 2mx. So what does that mean? It means the length from b to m is twice as long as the length from m to x. So the ratio is like 2 to 1. Part A. Express bm in terms of u and v. So bm is equal to 2/3 of the entire length bx. So bm will be equal to 2/3, and we can substitute for bx because we worked that out in part 1, minus 2v plus u. Last part of the question, part B. Using a vector method, show that the ratio ym to ya is 1 to 3. Show all working. So if we look at ym, how can we go from y to m? What other route can we pass? We can go from y to b and then b to m. Now remember that this is mathematics. There are always different ways you can use to solve the same question. So we could have gone ym by passing from y to o, o to x, x to m, accordingly. So you can substitute for yb, that's v plus 2/3 by bm, which we worked out in part 2, minus 2v plus u. And we can expand the brackets, so we're going to get v, 2/3 by minus 2 is minus 4/3 v, and 2/3 by u plus 2/3 u. And now we can simplify the v's. So we have 1v minus 4/3 v, that will give us minus 1/3 v plus 2/3 u. And for simplicity, let's factorize out the 1/3. So we'll be left with 1/3 by the brackets minus v plus 2u. And for ya, if we want to look at the diagram again, if we're going from y to a, we can go from y to o, and then from o to a. And yo is minus v, and oa is 2u. As such, we can say, let's go to ym again. And what did we recognize? We recognize that what we had inside the parentheses, inside the brackets, is ya. So ym is equal to 1/3 by minus v plus 2u. And we know the brackets. So ym is equal to 1/3 by ya. So if we bring the ya across, we can say ym to ya, that ratio, is really equal to 1 to 3. And we have shown the proof. This brings us to the end of CSEC past paper questions in the area of vectors. We have completed the first video with past paper questions from 2009 to 2013. Then the second was from 2014 to 2018. And this present video was from 2019 to the present. Feel free to look in the description down below and follow to the next topic that we suggest in order for you to follow in a systematic way in order to get a higher grade and a better understanding of the CSEC Maths syllabus.